Welcome again to the Low Vision series for Sub-Saharan Africa. This is the 5th lecture in the series, and after this there are 2 more to go. These lectures have been brought to you by Wales Optometry Postgraduate Education Center at Cardiff University and the Optometry Department of Malawi College of Health Sciences. We will look at magnification and prescribing magnifiers in this lecture. Most people who study low vision have a little problem when it comes to this point. They think there are too many calculations. We will try to make this as simple as possible and yet very relevant in practice. Do not forget to go to our website at www.wopec.co.uk to register for the opportunity to get a certificate for this course. You would have to answer some few MCQs. The URL on this slide will lead you straight to the registration page. If you have been following us, we have learned so much over the last few lectures, and now we are at the last stretch of the journey, which is prescribing solutions. One type of solution we can use in low vision is to prescribe magnifiers. We have all heard about magnification before. To most people, it means making things bigger, which is a good point to start from. To help us to understand magnification, we would like to remind ourselves that an object can only be seen when it forms an image on the retina. Magnification occurs if you are able to increase the size of the image of an object on the retina, which was initially too small and made it difficult to see the level of detail that needed to be seen. In low vision, people may sometimes have dark spots in their field of view, which is referred to as a scotoma. If we increase the size of the image on the retina, the area of loss stays the same, but the image on the retina is bigger and so easier to see. There are 3 fundamental ways we can make things bigger to the eye. The first is relative distance magnification. This form of magnification comes about when we change the position of an object without necessarily changing the height or size as shown by the diagram. When we bring objects close to the eye, the retina image becomes bigger. If we bring things very close, they will be out of focus, and so a high plus or a magnifier is needed to enable you to see things clearly. The second type of magnification is relative size magnification. The main concept underlying this form of magnification is to increase the size of the object without changing its position. This will result in a bigger image on the retina. The third form of magnification is angular magnification. As shown on this slide, the person is looking at a road sign which is far away from him. This results in a very small visual angle when viewing with a normal eye. But if the eye is aided with an optical system like a telescope, the image seen whilst using the telescope is said to subtend a larger visual angle to the eye, making the person see the image closer and much bigger. The angular magnification is therefore the ratio of the visual angle subtended by the image of the aided eye, that is whilst using the telescope, and the angle subtended by the object to the unaided eye, that is without a telescope. How does this play out in the real world? If somebody is reading a newspaper and can't see the print clearly, one option will be to bring the newspapers closer to the eyes to make the print look bigger and clearer. This individual is employing relative distance magnification. If the object comes too close to the individual, depending on the age and the state of his or her vision, he may need to accommodate, where appropriate, near prescription or a magnifier in order to see the images clearly. If he leaves the newspaper and goes for another newspaper with much bigger font sizes, he is applying relative size magnification. If he takes a break to watch the canoe sail off into the ocean and needs a telescope in order to see the rocking canoes and the brave fishermen who captain them, then he will be using the angular magnification. You may combine 2 or more magnification techniques to achieve the required magnification for a particular client. Manufacturers often mark the magnification of a magnifier, example 2 times or 3 times. However, a 2 times magnifier may not necessarily make things twice as big. It will all depend on how the individual uses it. The manufacturer indicates the amount of magnification based on the assumption that the magnifier will be placed in close proximity to the eye and the image is formed at the least distance of distinct vision. Well, most people who use magnifiers do not know about these assumptions and can use it in ways that suit them. Sometimes, The magnifier may seem not to be working due to wrong usage, and therefore you may not need to change the magnifier. You may only need to change how it is used. There are two formulae used by manufacturers in determining magnification. These are nominal and trait magnifications. Nominal magnification is obtained by dividing the dioptric power of the lens by 4. In this case, accommodation is not considered. However, some manufacturers argue that there is some amount of accommodation when the eye is looking at the image at 25 centimeters, which is referred to as the least distance of distinct vision. This distance is equivalent to 4 diopters. The 4 diopters translate to a unit magnification. The new formula derived based on this added assumption gives us the trait magnification formula of dioptric power divided by 4 plus 1. An example of the application of the two formulae is on the slide. For a 12 diopter lens, the nominal magnification is 3 times while the trait magnification is 4 times. That makes things a little bit confusing, but the good news is the amount of magnification the client experiences at the end of the day may not exactly be in line with these calculations. It is always based on how the client uses the magnifier. Now that we know the theories, let us see how well we can apply it in prescribing magnifiers. In order to prescribe a magnifier, you would have to determine the amount of magnification to prescribe. The methodology used will depend on whether the task is a near task, like reading a book, or a distance task, like watching a television. If it's a near task, you could either use the predicted or calculated procedure, or a plus lens builder procedure. With distance magnification, we would only look at the predicted procedure. Before we go on to prescribe, another factor we should consider is the kind of reading speed the client would need. If it's for spot reading, which means reading either single letters or single words one at a time, then you will need a reserve of 1.3 to 1, which means you need to get the person reading a line better than the target VA. So if he needs to read a prescription form with font size 8, then we need to first get him to read font size 6 letters, so he will be able to read the font size 8 letters well. Secondly, when it comes to reading fluently, like reading a novel or a newspaper, then we will need to go a bit further. Lovikitten and Whittaker recommend a reserve of 2:1 in this case, which basically means if the novel has a threshold acuity of font size 8, then we may have to give the person enough magnification to read font size 4 in order to fluently read the novel. You get the required reserve by dividing the threshold visual acuity by the largest figure in the ratio. For spot reading, we divide 8 by 1.3 because the reserve is 1.3 to 1, and we get an approximate answer of font size 6. The same applies to fluent reading. We divide font size 8 by 2 and we get 4 because the reserve ratio is 2 to 1. Quite simple. From this point, we will take a few examples and try to make use of this stuff we have learned so far. We will first look at predicting the magnification. We will begin by determining the near VA of the client, which in this case is N24, and the font size of VA of the task, which becomes our target VA. From our example, the client wants to read a book with VA of N8. So we have N24 as our measured VA and N8 as our target VA. To calculate the magnification, we divide the measured VA by the target VA. This gives us a magnification of 3 times. To determine the amount of dioptric power required to produce 3 times magnification, we use the nominal formula, which is M equals F over 4. If we work it out, we get a power of 12 diopters, which will be different if we were to use the trait magnification. The next step is to look at the distance the client should place the book from the lens in order to see it clearly. The appropriate place to have the best of view with your magnifier is to place the target at its anterior focal point. If you do that, to determine this distance, all you do is to find the reciprocal value of the power of the lens. That would be 1 divided by 12 diopters, which gives us 0.08 meters, equivalent to 8 centimeters. Our client will therefore use a 12 diopter magnifier and will need to use it at 8 centimeters. The predicted magnification has been known to produce underestimated values. Therefore, the magnification result obtained may need to be refined a bit. The second method is the plus build-up method. There is a great method because you really don't do a lot of calculation. It's like finding a near add, but this time you push the limit. The first thing you do is to take the client VA at 25 centimeters, which is a unit magnification, and therefore you will need a +4 lens in the trial frame. Determine the target VA as we showed in the previous example, and from that point you can build up the plus lenses with corresponding adjustment in the distance of the chart from the patient. You continue to build up till you get to our target VA, which is N8. At this point, we would have added +20 diopters and have a magnification of 5 times. The practitioner will need to find out which of the procedures works best for him or her. We did not use the reserve concept during our calculation because we wanted everyone to get the fundamentals right and to avoid any confusion. The target acuities we used in all our examples would barely get our patients reading very well. If we are lucky, they will be able to do spot reading. To get them to actually read well and fluently, then you need to apply the reserve rule. The target VA would either be a line better for spot reading or 3 lines better for fluent reading. Considering the clients we used in our example, the target VA will no longer be N8, but N6 for spot and N4 for fluent reading. Determining the magnification for distance task is also very easy. The predicted method is used. Determine the distance VA of the client and the acuity of the target. Our client has a VA of 660 and wants to read print from a TV screen, which requires a VA of 612 to see. If we apply our formula for determining magnification, we have a magnification of 5 times. We can then prescribe a 5 times telescope for our client to view the target. We should note that we do not have such a wide variety of telescopes, and all that we have done so far will be limited to the kind of optical aids available in your stock or on the market. This brings us to the end of this topic. We hope you have learned a lot. If there are any questions, do not hesitate to let us know in the comments section. This has been Dr. Abraham. Do not forget to log on to our website at www.wopec.co.uk and register for the opportunity to get a certificate for yourself. Your prefix will be WOPEC and your code will be 1234. Special thanks to Dr. Barbara Ryan, the Director of WOPEC, and Mr. Marek Karas, the Low Vision Module Leader at WOPEC, for their contribution to this work. I'll be waiting to welcome you to the next lecture. Bye for now.